Hey everybody, I want to write down a concrete congruence that'll motivate the solution to this problem. I'm going to write down 7 is congruent to 87 mod 10. And it's okay to string congruences just like you can string equalities. And notice this is also congruent to, let's say, 137. Okay, and I'll write mod 10 out here. And normally I think you put this parenthetically. So I'll put mod 10, envelop that in parentheses. Okay, y'all, that's supposed to read 137 there. Okay, 137. Now notice all of these are separated. Like this is separated by a multiple of 10, 80, right? That's a multiple of 10. 87 and 137 are separated by a multiple of 50, right? And even 137 and 7 would be, I say a multiple of 50. These are all multiples of 10. This is a multiple of 10. This is a multiple of 10. And 137 minus 7 is 130, which is also a multiple of 10. And notice they all have the same remainder, namely 7. Okay, 7, 87 divided by 10 has a remainder of 7. 137 divided by 10 has a remainder of 7. All right. And so that kind of motivates what we're going to do here as a problem approach. We want to find all the integers, and characterize is kind of vague. You'll see what I mean when we get started here. But we want to find all the integers n such that n and 13n squared plus 33n have the same last non-zero digit. Okay. Now notice that if n's any power of 10, it's automatically going to happen, right? If n is, say, 100, then the last non-zero, the last digit would be 0, and then of course 13 times 100 squared plus 33n would have a last digit equal to 0. So we're going to forget about the 0 last digit and just focus on the non-zero digits. All right, and so, but in any event, this statement right here is equivalent to this congruence for the very same reason all of this stuff is true or represents something. All of these objects here, all these three integers have a remainder of 7 upon division by 10. They all differ by multiples of 10, pairwise, okay? So that motivates this statement right here, okay? Now at this point, you can just carry on exactly like it's an equality. You subtract n from both sides, the 33 becomes a 32. And notice that 13 is congruent to 3 because 13 minus 3 is 10. 32 is congruent to 2 because 32 minus 2 is a multiple of 10, namely 30, okay? So you see, pretty quickly we've got to this equation right here, which is much easier to manage than trying to think about this any other way. Okay, so we're going to check all the non-zero remainders of 10, all right? And the only one that actually works here is n equals 6. Okay, so I'm going to write down n equals 6. I'm not going to go through each one. You can see that one doesn't work clearly, and it's very easy to verify here, but n equals 6 is the only one in this list of remainders, 9 remainders, that produces what we need here. In other words, this would be what? 3 times what? 36 plus 2 times 6 is 12. And isn't that equal to 120? 3 times 36 is 108 plus 12 is 120, which is certainly a multiple of 10, right? We'll just go 12 times 10. Okay. Now, so what we've shown here that n is congruent to 6. Okay, n must be congruent to 6 mod 10. We found one solution, and any other solution has to be congruent to that solution, mod 10 in this case. Okay. Now I'll just write down another congruence here that would we can check it out right now, folks. We'll just do n equals 6, right? So n equals 6. This comes out to be n equals 6, and we get 13 times 6 squared. This is our original expression. Plus 33 times 6. I believe that comes out to be that unlucky number you read about occasionally, 666. Okay, so there's the 6. There's the 6. Now let's try another one. N equals 16, right? N equals 16 is also congruent to 6. Oops, y'all, this should be mod 10 right here. Sorry about that. Mod 10. Let me erase. So that should be a mod 10 right there, folks. Sorry. All right, so let's do n equals 10. N equals 16. Okay. Okay, so that would mean 13 times 6 squared plus 16 squared plus 33 times 16. Okay, and I need to use a calculator for this one. So that's equal to, give me just a second here. So we're going to do 13. We'll do 13 times 16 times 16 plus 33 times 16 equals to, and folks, what I get right here is 3856. So you see, again, we ends with 6, and our n ends with 6, right? So there's two examples to verify that our claim is true. So again, the characterization of the n's that would do this would just be any n that's congruent to 6. Now we've got to be slightly careful with this, though. But I'm going to say n congruent to 6 modulo 10 is the answer. That would be the answer in terms of characterizing all the n. But you have to be slightly cautious about this, because notice that -4, n equals -4. Let me just write this right here. N equals -4 would be congruent to 6 mod 10, right? But you can verify what will happen here is your expression would correspond to 13 times -4 squared plus 33 times -4. If you have time, I'll just go ahead and do that for you. So it's 33 times -4. And so let's see what we have here, folks. That would be 16 times 13 plus 33 times -4. And yeah, what I got here is 76. Now I think that's right. But notice we do get it ending in 6, but -4 it obviously doesn't end in 6. So you get 6 here, but you can't use negative numbers, which wasn't real clear to me until I just noticed it. I didn't really think about it. I thought all the integers congruent to 6 would work, but it doesn't on the negative side, and it just doesn't. I'm not really sure theoretically why. It just doesn't. But in any event, this is the final answer, and I should say in greater than 0. Okay, folks, thanks for viewing.